Hello? Hello? Okay, it's working. So yeah, I found out last time. Hello everyone, whoever is on the stream or waiting to be on the stream. I found out that the audio wasn't working for the majority of the stream, and it's because or not the majority of the stream, but a good portion of it. And I forgot to add the microphone to this new scene. And so if you know how OBS works, or OBS is the streaming service I'm using. I forgot to add the microphone. Rookie mistake, just like always. So we're still learning. I'm definitely still learning. We're all learning together, hopefully. Yeah. So that's that. That's okay. I had to cut out a lot of the one of the lessons, but that's okay. I'm pretty sure I can go over it this time. So for today, we are going to be going over processing even more, and we're going to start our project. So that's exciting. Yeah, I'll wait a little longer for everyone to just hop in. I'm excited. We're gonna be doing processing. So yeah, if you guys are watching, go ahead and yeah, if you haven't downloaded processing already, this is a wonderful time to do so. Just either go on to processing.org, download it, and then open it up, and you'll see this little screen here that I have right here. It's cool. It's cool stuff. Yeah, I'm still trying to figure out the best way to really get this to work. I'm not exactly sure yet. Okay. How I should like set up the screen and stuff, because I might make my head smaller. Maybe that's better. I don't need such a big head. Let me just try running this real quick. Oh no. That's not fun. Okay. Let me just stick that right there. You guys can go ahead and see that little box. Alright, so that's enough people. I guess we'll go ahead and start. Okay. Hello everyone, welcome to day, I think 9 of one of coding Java. So we finally did it. We're past the Java stages, and that means I don't have to create any more silly Google slides. Now, since we're going to be working with processing, we're simply going to be learning with processing. So hope you guys are ready for that. So if you haven't downloaded processing yet, go ahead and go to processing.org, link in the description, hopefully, if I remember. And download it, and then once you have it, you'll open it up and it'll look like this. Now your sketch number might be different, but all that is it's a temporary file name. So we're going to be creating Java programs using this. And again, processing is very similar to Java. in syntax wise. And so a couple things that you're missing out is when you're creating your little sketch, right, or your file, you don't have to have the word class. Now there is a way to create classes because classes are still useful, and I will get into that soon. So let's just go over what we're going to be working on. We're going to be creating a Flappy Bird demo, all right? Because Flappy Bird is easy to use. So let's just put some comments on the top of our on the top of our code to show everyone what this is all about. This is going to be version 0.0.1. I don't know. 0.1. All right. So a couple things that we're going to have to go over. First, let's start off by setting up our setup and draw function. And if again you don't remember from last time, or that part got cut out, a setup function is simply the first thing that runs. It's like the main function. Now the draw function is like a while loop, though it repeats over and over, but it makes sure it doesn't go over a certain frame rate. So you have your setup function that will declare all your variables and set everything up, and then you have your draw function that will draw things to the screen. So let's create those two functions. Because they're not returning anything, they're going to be of type void. And in processing, you rarely have to use the public keyword because it already knows that most of the things you're going to be using are public. So void setup, right? Setup. Now it highlighted this specific function in blue, and you could see that if you create another function, right, say add, it doesn't have the same blue, and that's because processing knows that the setup function is special. It knows that, hey, this is going to be specifically used for setting things up, so I'm going to highlight it in bold. Now and our second function, void draw. Now if you guys are used to Codiva, you're going to just have to get used to using a different IDE, which is processing. And a couple things that you'll note is that it doesn't like add in the other parentheses or the other curly brackets sometimes, or most of the time, so you're gonna have to add them in yourself, which isn't really a problem for us. So what are we gonna have to create? Well, what is in Flappy Bird? We'll have to go over game design. You have to figure out what you have to add in first. So I guess I do have a whiteboard, and I guess I can use it. So let's see. For the first time in one-up coding, we're gonna use the blackboard. The whiteboard. It's a whiteboard. What am I doing? So there's two classes we're going to create. And again, a class is just a blueprint for an object. What is an object? It's just something that has multiple properties. Something that can't be described just by one variable. So we're going to have, we'll start here. I don't know why I'm writing so big. We have to have our bird. That's not very visible, is it? Okay, let's go into if you remember, this is okay. If you remember what the sort of manager class is, in this folder, in this sketch, we're gonna have the manager class. And so how do we add in another class, right? The best way to do it is to just create a new tab. And what a new tab is uh, it's not creating a new file, or yeah, it is creating a new file. It's just allowing us to use multiple files to keep our code clean. We don't want 1,000 words just top to bottom. We want to be able to look through them a lot easier. And so we're going to create our bird class in here. If you can't see it, you can't really see the window, but go ahead and create a new tab and just name it bird. And what's going to be inside our bird file? The bird class. Class bird. So we have our bird class. Now what do we want it to have? Obviously we want it to have these specific constants, right? Or these specific variables. And yeah, let's just go ahead and give it that. Now, if you remember what a class has, it has a constructor. Now the constructor, all it is, hey, what do I want it to do right when I start this? We're also going to define the variables right here. We're going to give it a y, right? Now we're not going to put anything in the y yet. We're just going to have that be the constructor strop. So we're going to create give it I guess you can give it the velocity first, right? You can give it the gravity as well, and we're going to give it lift. Now let's create the constructor, and all the constructor is, it's like a function, except it has no return type, right? And the name of the function is going to be the name of your class. So we're not going to give it any variables. Maybe later on we can create different birds with different jumps, different lifts, right? Different gravities, different velocities. For now, let's just focus on creating one. So our bird class, it'll have a y. Now we're going to start the y around 25. And if you imagine, right, so we're gonna start, yeah, at 25. This dot, and remember what the this dot key is. It means, hey, for this specific bird, I want it to have this certain variable. So this bird, this dot, I want it to give it y of 25, and I want to give it a velocity of 0. We don't want it to be moving at the very beginning. We want it to just stay constant. Start as not move. Oh, I spelled velocity wrong. Okay, we're gonna give it a gravity, right? This dot gravity. Let's say let's just pick a small number. What? Yeah, let's pick 0.2. I think 0.2 is small enough so that it doesn't like drop down horrendously, but it also doesn't sort of float. We want it to be sort of challenging. So whoops. And then we're going to give it a lift. Now, this is also arbitrary, right? It doesn't really matter, but we're going to give it around -5. And all the difference is the lift has to be greater than the gravity. Why? Because otherwise, when you jump, you won't jump past the hold of gravity. You just, the gravity will still push you down. So we're going to, let's go back to coding this, right? So we have our constructor, right? Defines the base variables. We're gonna create, let's just start with the jump function, right? So what does the jump function do, right? Well, all we want it to do is increase the velocity, right? You don't want to just increase the y position, because then it'll sort of jump like really statically, right? Or it'll jump like really constant amounts. So instead of having a fluid increase, right, a fluid jump, it'll sort of just like create these really static hopping. So we're gonna have it increase the velocity instead. Oh, one more thing. Why is gravity 0.2 and why is lift negative? All right, again, why is gravity positive? Why is lift negative? Well, shouldn't it be the other way around, right? Gravity should bring you downwards, right? It should decrease the velocity so that you're going downwards. Lift should bring you upwards. But again, you have to remember that, I'll stop going to the whiteboard. You have to remember that in our processing folder, right, y going downward is positive. So if we want it to go downward, we have to increase the velocity. If we want it to go upwards, we have to decrease the velocity. So it goes negative, it goes upwards. So jump, again, we're going to increase the velocity by the lift. That's all we're doing. All we're saying is, hey, make our velocity, or how much our y changes over time. That's the velocity. How much our y changes over time. We want to decrease that. So it goes upwards. We're going to have our update function, right? All this is background work. We want to say, so yeah. What we want our update function to do is say, hey, apply gravity, right? And then just move the coordinate based on its velocity. So we're going to add gravity to our velocity. Say, hey, I want to start increasing our velocity so it starts going downwards. And then we're going to increase our y by our velocity. This velocity, oh my, this stuff velocity. Okay, so if I make any sort of small errors like that, oh okay, you can this dot lift. We're going to yeah, so we're gonna apply gravity. Say, hey, I want to sort of increase the velocity so that it goes down, it starts going downward. But I also want to and I also want to increase the y coordinate by its velocity. So again, I'll repeat it one last time. Velocity is just how much y changes over time. So at every single second, at every single time step, we're going to increase the y by its velocity. That's all our update function is going to do. And we're going to have our draw function. Oh, not draw function. We're going to call it show. Why? Because the draw function's already taken up. It's a special keyword, so we don't want to use it. It's like naming a variable this or new or float. We don't want to do that. We want to avoid naming our variables or functions as keywords. So void show. What do we want it to do? We want it to draw our thing to the screen, right? Now there's all these drawing functions and all these art sort of animation functions in processing that you kind of have to memorize or know. So one of them is fill. Fill means, hey, everything I draw from this point on, I want it to have this color. So you're gonna have to give it an RGB value. And RGB is how red you want it, how green you want it, how blue you want it. I want to draw something that's black, a black dot that moves up and down. So I want it to give it no color. So if you know, yeah, color theory or whatever, I don't know what it's called. If you give it no red, green, or blue, it'll turn out black. Now, how do you add the max red, green, and blue to turn it white? It's 255. So it's 255, 255, 255. That will give you white. And that's what we're going to color our background, just so that there's sharp contrast, right? So, and just to make this simple, I'm going to make our bird a circle, right? It'll be a 3x3 circle ellipse. It's just this small dot moving on the screen. And how do you do that? Well, processing has this built-in function called ellipse. All ellipse does is, hey, draw ellipse at this certain coordinate and size. So how are we going to do that? Well, the first number will be the x-coordinate, right? You see here it has 4 parameters: an x-coordinate, y-coordinate, a width, and a height. So our x-coordinate, because we're not going to be changing our x-coordinate, right? It'll just sort of stay constant. Let's just put it at like 25. It'll be quarter across the screen, and it won't change. Now our y-coordinate, we want it to change. And what do we want our y-coordinate to be? This dot y. We have 2 more variables, the width and the height. Let's just make it small, a 3x3 circle. There you go, semicolon. Bam, we finished our bird function, right? So let's go back to our sketch, right? We're gonna say you always want to declare global variables. If you remember my scope lesson, right? You want to declare global variables and edit them inside of your functions. So we're gonna say, hey, we want a bird, right? An object of type bird. We're gonna call it bird, right? We're not gonna give it a value yet. We're gonna give it a value in setup. Now you could give it a value here, but it's not advised. Sometimes we want setup because it runs first, right? It's the first thing it runs. We want that to control what our variables are. Why? Because sometimes your code will jump around and it won't. Basically, it'll miss timing, and if you assign it here, say equals new bird, right? It won't know that. It wouldn't have assigned it in time. It's weird. Just follow me, right? We want to give our bird, right, a new value, right? We're gonna create a new bird object, right? Calling on the constructor of the bird class. We're gonna say, hey, create a new bird for me and put it inside bird. Now we're gonna just say, hey, background. We want our background to be 255, 255, 255. We're gonna say, hey, give me a white background, and we're gonna update our bird, and then we're gonna draw our bird or show our bird. Just as simple as that. We're gonna say, hey, we have our game object here, right? A bird class or a bird object. We want to update it. We want to update it, right? Increase its velocity and draw it. Let's watch this. Now, it might end up really weird, and I'll show you and explain why. Oh no. Hold on. It's not capturing the right window. No. Okay. Okay. Sorry. Here, let me draw it one more time. There is an error. Let me just draw it. Oh, it drew itself and just fell instantly. How do we avoid that? Well, let's just lock our bird between certain heights, right? So in our update function, we don't want it to just fall continuously. We want to say, hey, if it touches the ground, stop. Now in the actual game, if you hit the ground, you lose, but we'll work on adding that in later. For now, we'll just make it stop and stick in place. So if we're gonna create an if statement, right? So if this dot y is greater than height. Now what is height? Our code or our compiler, right, or our processing gives us a specific variable called height that says, hey, this is the height of the screen. The screen we're using, it's the height. It just yeah. If you want to learn how that works, you can look up the processing documents. But for now, you could just believe me. The height is just the height of the screen. So if the y is greater than the height, right, we want to say this dot y equals height. We want it to set it at the height, so it just sits at the bottom. Now we also want to say this dot velocity equals 0. Why? Because we don't want our velocity to jump up and down still while it's sitting at the bottom. Now we're gonna use the same exact. Let me just copy paste this. We also don't want him to jump all the way up, otherwise that won't really be fair. Oh, yes, okay. We want to say, hey, at 0, right? Or 0, which is the top of the screen, This is the top of the screen. We don't want him to jump past that point. And later on, again, we'll be working on how to add in a game over, game over factor. But for now, let's just work on this. Now, one last thing. Let's just draw this. Let's just run this. Hey, it's sitting. Now, if you know how to play Flappy Bird, or if you ever play Flappy Bird, you'll know that I missed something. What did I miss? I can't jump yet. I didn't add anything that allows us to jump. So how do you do that? Inside of our manager class or inside of our setup and draw functions, we're gonna add one more function. It's called key pressed. And you notice, hey, key pressed is also bold. That means it's a special function. That means processing gives this function certain abilities. It gives it certain things that we can use, and it knows what this function is, right? So we're gonna say, hey, if they press the space bar, right? And when you say key pressed, inside of the key pressed function, processing gives it a specific variable. What I mean by give is it means you can use this variable that has a specific value when you call it. And what that variable is key. Key inside of key, it's a variable, right? It's a character variable that stores the key of the key that they just pressed. So we want to say, hey, if it's a spacebar, right, which is just an empty space, we want to say bird.jump. Okay. Now let's see if this works. Hold on, I'm missing something. Well, this is awkward. You guys are watching me fail. Let me figure out what's wrong with this first, guys. What did I do wrong? See, I actually wrote notes this time. Whoa, whole new Luke. It should be working. Here, let me just try running it again. Let me see if... Oh, okay. Okay, so yeah, we ran it and it works. You can press jump. So we created our bird. Isn't this amazing? We can always alter how much we want it to jump, how big the screen is actually. You can edit the screen size right here. In our setup function, you say size. Let's say 100 by 100, which I think is the default one. And it is the default one. So you can increase the height of your screen, right? You can increase the gravity. Maybe it pulls on them harder. You can increase the lift. Maybe you want them to jump higher. I'll let all the editing, that little editing, up to you, how you want your game of Flappy Bird to work. So we're almost done. Let's just save our game. Go ahead and click on File. You won't see it. Click on File, click on Save, right? And you'll open up your folder. You can store it anywhere you want. And name the folder anything you want. Oh no. I froze my computer. But once you're done saving, go ahead and good job today, everyone. We'll be working on adding in the pipes and adding in any other elements we want later on. Thank you guys so much for watching. That's it for today. I will see you guys in the next video. Okay, so stream viewers, that's amazing. You guys just made a little game for yourselves. We're gonna be working on collision detection and a lot of other things next. So I hope you guys are excited. Um, yeah. So if you guys have any questions about processing or about what we're going to be doing next or about how this code works, how the physics work, go ahead and ask. I will help you guys out. We'll be starting the next lesson soon. I'm just trying to yeah, okay, my computer was frozen for a second there. So I hope you guys are excited. We will be. I hope you guys can. Yeah, you guys can hear me. All right. Hopefully you guys can hear me. Uh, we will be working on adding the pipes in, and I have to figure out how to do that first. I know how to do it. I don't know how to do it specifically. um, uh, okay. Okay. Yeah. All right. Enough stalling. Yeah. Oh wait, all right. Sorry. Now is your break. We'll be having our break from 11:05 to 11:15. So, go ahead, relax, go to the bathroom, drink some water. I definitely need to drink some water, and we will get right back into it. Uh, Yas. Oh no, guys. Oh no, I went overtime. I'm sorry, the break was a little too long, a minute too long. That's okay. We will be starting very soon. Do not fret. Um, uh, this is awkward. You guys are gonna have to deal with me. Hold on. I'm preparing for the next lesson. I should have done this beforehand, but I guess I'm doing it now. No need to fret. We will get on with it very soon. Am I doing this right? Hmm. Ah, okay. Okay. All right, fine. All right, we're ready for the lesson. All right, enough of me stalling. Okay. Okay, so hopefully you guys are up to date. Hello, everyone. Welcome to day, I think, 10 of Java coding. Oh man, we're on day 10. Uh, Today we're going to be going over how to make pipes and add those to our game. So, oh my gosh. So I guess we're gonna. Okay, it's on here. Okay, it's on here. All right, so the mic is back. Ah, I'm not redoing all of. Okay, it's on here. Okay. Alright, viewers, so I made a little editing mistake and I forgot to add in my mic for the whiteboard parts. Oh my gosh. Thank you so much, Power Vertigo, for pointing that out. You saved me a lot of sadness. Hello, viewers. I'm sorry, I made a little mistake. Let me correct this. I had my mic off whenever I did the whiteboard parts. So all I wanted to say is, for our bird, we want to have a y value, right? What the y coordinate will be, velocity, which is how much our y will change over time, gravity, which is just a number we'll add to the velocity over time, and lift, which is just how much we want our bird to jump whenever we press the spacebar. And so if you check out the coordinate plane of our box, it actually starts at 0 here, 0, 0, and to go this way, we increase our x, and to go this way, we increase our y. So if we want our gravity to go downwards, if we want to add gravity, we increase our y, and we decrease our y to go upwards. So the couple of functions that we want to have are our update function, right? All our update function does is it adds all the background work. It does all the physics, it does all the adding and subtracting, and then we have our show function. All the show function does is it draws our image. It does all the visual stuff. And we're gonna have one last function for our bird, the jump function. All the jump function does is it has our bird jump. Okay. Okay. So everyone, let me go ahead and clean the whiteboard with the power of editing. Okay. The stream viewers, you guys get to watch me clean the whiteboard. Ah, man, why do I always mess this up, man? I always have my mic off or something. That's okay. Alright, so okay, hopefully this time I don't make any more mistakes. So this time you guys actually get to see the whiteboard in action, and my mic will not be muted. So we just finished making the bird, alright? And the bird class has all I showed you guys how the physics work. I showed you guys how the drawing works. Now we're gonna apply the same concepts towards making these pipes. So what is the pipe, right? We're gonna have our box here, right? Our 100 by 100 frame, and we have our little bird here. We have to create basically two rectangles, which will both be drawn by the pipe. And let's see what kind of variables we're gonna have to add to our rectangle. Is my mic good, everyone? Okay, I hope my mic is good. Okay, now it's good. All right. So what kind of variables do we want? Well, we already have the height of the entire frame. That variable is called height. And so our code actually knows what height is, processing knows what height is, and it will give us the height whenever we need it. That's one variable. What about this certain height here? How do we measure this height? Excuse me. Basically, up until we're gonna have a variable. Okay, let's start first with x variable. So let's just name this certain value x. Our pipe will have a value of x, right? And that's just going to be the starting position. And this little width here, we're going to name that w, right? We don't want to name it width, otherwise it'll get confused with the entire frame width. So we're going to name that w. What other kind of variables are we going to have to add to our pipe? We're going to have to add this height right here. It's the space. We're going to call this space, right? This is how low this space will be, and we're going to call this space width. So it's the width of the space. Now we could we're gonna randomize the space because we want to have a different space every time. We could randomize the width as well, but for now let's just stick with measuring the width, or measuring. Let's just keep a constant width for now. Now you might say, hey, what about this part? Do we need a variable for that? No, and the reason is because we can represent this height as height, right? The entire height. If you remember math, this might this might hurt you a little on the inside, but this value right here is actually this total value minus these two values. So if you ever have you never want a variable that's kind of redundant, that you can represent using really other variables. So, and we also want a velocity. And if you don't remember from last video, or I ended up cutting it out somehow, velocity is just how much our x will change over time. And so we'll keep that constant. And the reason we have a velocity instead of just changing the x over and over again is because if we just keep changing the x by constant amounts, it'll get really like staticky. It'll end up jumping across the screen, and we don't want that to happen. So now that we have that, let's get into the code. Okay, this is our little coding block here. This is where we left off last time. We're gonna create a new class, right? Wow. We're gonna call it pipe. All right, inside of this pipe file, we're gonna say a pipe class. Now, what we're gonna have? Again, we're gonna have these variables that I just said. So we're gonna have a float x, right, which is the x coordinate of the pipe, which will move across the screen over time. We're gonna have a width, right? We're gonna have a space, which is basically where this space starts. Where this space width will start. It'll just be another y coordinate, basically. A space width, right? We're gonna have also, what else are we gonna have? A velocity. There you go. Float velocity. So we're gonna say we're gonna create our pipe constructor. Again, the first function that runs when we create our pipe. We're gonna say this dot x equals. Let's just we're gonna start it at the width of the screen. It'll start on the very right, which is the width of the screen. We're gonna say not float, this dot w, we're gonna give it just a height of like 5 right now, which is just barely bigger than our Flappy Bird. This dot space. Now here's where a function called random comes into play. We're gonna we want our random space value but to be between 0, right? And we don't want it to end up at the height, at the width. We don't want it to be a random value between 0 and the width, because if space is over here, then the empty box that the bird can jump through is below the screen, and we don't want that to happen. So we're gonna say here's a cool a function that processing gives us, just again to simplify all the different syntax pieces that we have to use. It just gives us random. We're gonna start it at 0, and we're gonna end it at height, right? Height of the screen minus space width. Now you notice, not space width, this dot space width. Now you notice I messed up here because I declared the space, I used space width before I declared it. So I'm gonna say this dot space width. Let's just say 25 for now. It's around just like a quarter of the screen, just to give enough space for the Flappy Bird to jump. And we're gonna say this dot velocity. Let's just give it what, -3. And again, it's negative because it's moving leftwards. Now to have it move rightwards, we'll give it a positive velocity. But because we want to move left, we're giving it a negative velocity. So what kind of functions do we want it to have? We want to give it 3 functions. Now I will show you the 3. Obviously, when you're creating any object or anything that appears on the screen, any sort of different entity, we want to give it 2 functions: the update function and the show function. So update, inside of update, we're going to say this dot w, or this dot x minus plus equals this dot velocity. We're going to say, hey, just increase the velocity or decrease the velocity over time. And also we're going to have the show function. This draws the rectangles. We're going to draw 2 separate rectangles. And the rectangle function, rect, is very similar to the ellipse function. It gives you 4 values, right? We're going to have it start we're gonna draw the top one first, right? It'll have an x value, right? Rect, the 4 different values are its x, y, width, and height. So what's the x value? It's this dot x. What's the y value? We're going to start it at 0 because it starts at the top of the screen, which is height of 0. We're going to have it a width of this dot w, and we're going to have it, its height will be the space value, how tall this space value is. So we're going to draw the second rectangle. So what is the height of this rectangle? What's the y coordinate? Or the x coordinate will just be this dot x again. The y coordinate will be this dot space, where the space starts, plus the width of the space. That will give you the end of the space. What else do we need? We're going to need the width and height. The width is still the same, this dot width. And the height, again, what is the height of this? It's the total height, which is height, minus this space, the sum of these two spaces. So we could say minus this dot space and minus this dot space width. That way, yeah, it'll draw in the right area. Now we need one more function, and all this function will do is tell us whether or not this pipe is off the screen. Once it's left, we don't want to keep creating pipes. Otherwise, we're going to have an infinite number of pipes that we don't want to deal with. It'll just stain our memory off the screen. So we want to be able to tell us, hey, is this off the screen? If so, we can delete it. So we're going to say this one's not going to be void. We're going to create a Boolean called off screen. Now, if you remember what this value here is, the keyword here, it's, hey, what am I going to return? So if this dot x is less than 0, right? 0 is the very left of the screen. If it's left of the screen, we're going to say return true. Return true. Otherwise, just return false. We always want to make sure we're returning something. So if it's true, return true. If it's false, return false. Now we're going to go back to our Flappy Bird class, and we're going to say, hey, now what do we want? We're going to create an array list. An array list is just a list of objects that have a variable length, right? And it has a variable length. A variable length meaning the length of it can change. Why do we want it to change? It's because we're going to be adding in pipes over time and deleting pipes over time. We can't do that with a regular array. So we're going to create an array list. So array list of type pipe, right? We're going to have a bunch of pipes, and we're going to call this variable pipes. So pipes will equal a new array list. So we're going to create an array list object that can store pipes inside of it. So it's just like creating any other object using its constructor. Now, here, we could do it before our bird functions. We'll just say, okay, we're going to have two different loops here. One to say, all right, update and show every single pipe. The second one will loop through and say, hey, if there's a pipe here we don't want because it's off screen, we're going to delete it. So if you remember how to loop through an array list or even just a regular list, we say int I equals 0, right? We're going to declare a counter variable, something that we can count with, and we want it to go through the entire list. So what is that? How do we do that? We're going to say pipes.size. Pipes.size is just the length of the list right now. How big is it right now? So in order to loop through all of it, we're going to say, hey, create this counter variable, have it go through every index of the list, and increase I over time. So I will, we're going to say pipes.get. That's how you get a certain value from this list of I. Now, imagine this as one of the pipes. So we can declare functions using this pipe. We're going to say update it, right? And then show it. So we're going to update and show every single value. Now, I will get into a very important concept very soon. So we're going to declare another one to loop through all the pipes again. Now, why didn't I just combine the two? Well, let's go to the whiteboard. So I'm not going to erase all this. I'm going to use this space right here. So you have your list of items, right? I'm going to just say, give it 3 spots right now. 0, 0, 0, 1, 1, and 2. These are objects, right? They're integer objects. They have the index of 0, 1, and 2. 0, 1, 2. Now let's say we're looping through all of it, right? And our loop will say, all right, start at I equals 0. Oh, you can't see that. Equal 0, right? Then I will equal, go to, it'll increase, right? Go to 1, and then 2. Now the length of this is 3, right? The length of this is 3. There's 3 things inside of it. That means it'll go up until 0, 1, and 2. It won't go until 3 because 3 does not is not less than 3. It's equal to 3. So it'll go to 0, 1, and 2. Now let's say we want to delete one of these because it's off screen, right? So we're starting at 0. We're going to 1. And what if 1, we have to delete it? So we delete 1. Get rid of it, right? Our new list is 0, 2. Now you notice something. We hopped. We went here. We went here. Now we're at here. All right. I equals 2. But the thing is, our list, the length is now 2. So it'll skip over 2 completely. Now the danger of that is, what if 2 has to be deleted as well? We just missed deleting 2 because when we deleted 1, we moved the index over. So we want to avoid that. How do you avoid that? The best way is to loop through this backwards. Because if I say, hey, start at 2, then go to 1, then go to 0, if I delete 2, I'm still going to 1 after that. And I still check number 1. And then after that, I still check number 0. So we have to avoid index skipping. All right, so let me show you guys how to do that. Int j, we're going to declare a new counter variable. Again, the name of the counter variable doesn't matter. I'm just picking really small variable names. So we're going to start it at the pipes.size -1. We want it to have the index of the last variable. And the index of the last variable is pipes the length of the variable -1. Because we're starting our count at 0. We're going to say I is greater than or equal to 0, right? As long as it's as long as it goes up, as long as it goes to 0, as long as it goes to 0. All right, and then oh, not I, j is greater than or equal to 0 because we want to include 0. That's a part of the index, and j plus plus or j minus minus. We're going backwards, so we want to decrease. So pipes, it's very similar very similar process. We're going to say, hey, is pipes.get of j, which means is this specific pipe less off screen? So we can say off screen because we made a function off screen. If that is true, right, this gives us true. So we don't have to say equals equals. We could say equals true, but this is the exact same thing because this gives us true anyways. If true equals, if we say equals true, we're saying, hey, is true true? And if true equals true, it'll give us true. All right, if that confused you, don't worry about it. You can just skip equals true for now. Excuse me. So if it's off screen, we can say pipes.remove j. And if you remember what remove j is, excuse me, it says, hey, remove this specific index of pipe. So now we're adding and removing pipes, and we're updating. Oh, I missed one thing. I forgot to add in pipes. Okay, so we're gonna declare one last thing. All right, I know this is a long lesson. Let me just try to finish this. We're gonna say our count. We're gonna declare a counter, right? Now, why? It's because we want to create pipes at regular intervals. What a regular interval is just I want to create a pipe every like 10 seconds or every 10 frames. And so we do that by saying int counter equals 0 if counter modulus like 50, right? Oh, that's not a modulus. Modulus 50, if counter is divisible by 50, what that means is, hey, if I'm increasing counter like one by one. Counter equals what 0, 1, 2, 3, 4, 5, 6, 7. Every 50, if every 50, as counter increases, at every multiple of 50, the counter modulus 50 will equal 0, right? Modulus is the remainder. So at every multiple of 50, if I divide by 50, the remainder will be 0. So I want this to happen every 50 frames, right? I want to say pipes dot add new pipe. So again, if you call on the constructor, say new pipe with parentheses, you're creating a new object right there. So I'm creating an object and I'm putting it inside pipes by adding it. Now I'm missing one thing, and that is I want to increase my counter by 1 every frame. Otherwise, counter will always equal 0. It'll always be a multiple of 50. 0 is a multiple of 50. It's 0 50s. And I'll be adding in an infinite number of pipes. So I want to increase my counter. So I missed one more thing. Let's just go back here. I forgot to say fill 0, 0, 0. All that is hey, I want to color my rectangles. Otherwise, they'll come out white and it'll be the same color as the screen. So let's run this. Oh no. So let's run this, and this is what I got. I got this, oh no. Where did it go? Okay. So it's a little bit laggy. That's just because I'm running a bunch of programs right now to stream my software. I'm running processing. So you'll see that it's going very fast, and I can decrease or increase the velocity however I want. So if I wanted to decrease the velocity, right, I could just go here and say velocity minus equals -1 instead. So let's run this instead and see how it goes. Now it's a lot easier, right? I guess. I'm still really I was always really bad at this game. So if you guys you can test yourselves. Now we're done creating the pipes, right? We're done creating and drawing the pipes. Next time we'll be looking at how do we add a collision, right? Because we want you know, we want a game over. We don't want this to just go forever. We're gonna add a score, collisions, and I guess, yeah, just more graphical properties, more things that you guys can add in for fun. So thank you guys so much for watching. This lesson has been a lot of fun. We'll keep working on it, and I hope you guys enjoyed it, and I will see you guys in the next video. Okay, streamers. Oh boy, or stream viewers, how was that, guys? How was that? Was it interesting? Okay. Yes, okay. So, I guess there are multiple ways for me to solve the mic turning off in the first video. I could add subtitles or just captions so that I can just say, the mic cut off, here are the captions. That's really viable. That's completely viable. There are a bunch of different ways I can do it. But so because it's basically 12 and I don't want to start a new lesson and I want to give you guys a bit of break to sort of just process everything. I want you guys to process everything that's going on and to try things yourself, really. I might give you guys an assignment over the week to have you guys test out the different things you've learned. Other than that, thank you guys so much for watching. The couple of you that are watching, this is exciting, and yeah, I'm excited. You guys are learning processing. You guys are learning how to draw these stuff, all this cool stuff. Yeah, okay. I will try to make the stream better. Obviously, I'm human. I'm only human. I'm trying my best. If there are things that go wrong, tell me in the chat. I might answer a little late. That's okay. The stream's basically over. Yeah, so if you guys have any questions, curious about what you can do with processing, what other things you could do, If you need help, if I went over something really quickly, go ahead and ask. I will be very happy to help you all. Thank you guys so much for watching. I'll keep it up for like another 9 minutes, and if for any questions other than that, I will end the stream there. So I'm gonna grab water and come back, and if there aren't any questions, I guess I'll end the stream there. Thank you guys so much for watching. I'll see you guys soon. Alright, no questions as always. Aw, Crick missed the stream this time. I feel bad. Maybe he'll be back another time. But yeah, it's getting exciting, y'all. You guys are learning how to do all this cool stuff. Oh, I named the stream wrong. It's actually okay. Come on. I named the stream wrong. Alright, it's fine. Next time, yeah, whatever. I need so I went a lot quicker this time, and I did it mostly because I wanted I wanted the streams to be or the lessons to be shorter. I was not only because I was tired of editing like 5-hour streams, but also mostly because I feel like a lot of people are not as willing to watch it when they see that the lesson's like an hour long. So I'm trying my best to keep these around like 20 minutes long, but obviously I'm not doing so well with that. So we're all learning. We're all trying to improve. This is relatively smooth. I like this. Oh, I'm lagging. No. I'm really bad at this game. Why am I so bad? I just don't have the timing. You know what I'm saying? So obviously it looks really boring right now because everything's black and white. We can add in colors. We can add in I don't know, all kinds of cool stuff. So we can add in a backdrop. So yeah, oh, forgot. If any of you guys have now you guys are just watching me play Flappy Bird. So if you guys have any ideas on what I should do next, or maybe what kind of features you want to see in this Flappy Bird, like how do you add in color, I'm completely open to suggestions on like Google Classroom. You can ask me personally, ask the email. Just tell me, hey, would you mind going over this? How do you add this into this game? How do you do this? Obviously I'm gonna go over the core of it. How do you add like collision, and how do you draw the things? But you guys can totally ask or totally go over what kind of miniature features, any like special details that you'd like to see implemented into the game. So I think that's it for today. Thank you guys so much for watching. Again, contact me. I have a lot of free time, and I will see you guys in the next video.